In this video, we will discuss about vectors and vector addition. In physics, some quantities only need a number and a unit. These are called scalars. Examples include temperature, speed, mass. Other quantities need both a magnitude and a direction. These are vectors. Examples include displacement, velocity, force, and acceleration. In two-dimensional motion, vectors are essential because direction matters. Now let us look at how vectors are written. It is important to understand how to identify a vector when you read a textbook and also how to indicate a vector when you write. Usually, we show an arrow on top of the variable to indicate a vector. In some printed media, bold fonts are used to indicate vectors. When we are talking only about the size of a vector, we call that the magnitude. We can write the magnitude as a letter or a symbol without an arrow on top of it. And in print, usually use an italic font for that. And we can also indicate it as the absolute value of vector A in this example. The magnitude has units and it is always positive. When writing a vector by hand, we usually put an arrow over the letter like vector A shown here, and to indicate the magnitude we use the absolute sign as we mentioned before. Vectors are usually represented by arrows. The direction of the arrow shows the direction of the vector. The length of the arrow shows the magnitude or size of the vector. For example, suppose we are drawing force vectors. If one force is 8 newtons and another force is 4 newtons, then the 8 newtons force should be drawn twice as long as the 4 newtons force, as long as we are using the same scale. This is why the scale is important when we draw vectors. A longer arrow means a larger magnitude, and it does not mean that it is a different type of quantity. Now let us connect this idea to displacement. This example shows the difference between path length and displacement. A person walks 9 blocks east and then 5 blocks to the north. So the total walking path is 14 blocks. But if you think about the displacement, that is the direct distance from the starting point to destination. So that is about 10.3 blocks. And also the angle of this displacement vector creating to the positive x-axis is 29.1 degrees. So the displacement depends only on the starting point and the ending point. When motion happens in more than one step, we need to add vectors. The graphical method for adding vectors is called the head-to-tail method. First, choose a scale and draw the first vector. In this picture, you can see this is the first vector, vector A. And then place the tail of the second vector, this part, at the head of the first vector. So this is the head of the first vector. The resultant vector is starting at the tail of the first vector and ends at the head of the last vector. Here, the resultant vector is given by vector r, which is equals to vector a plus vector b, and this is the resultant vector. The same idea works for more than two vectors. If there are several vectors, continue the same head-to-tail process. Place each vector at the head of the previous one. After all vectors are included, the resultant is still drawn from the tail of the first vector to the head of the last vector. This method gives a visual estimate for magnitude and direction. But for accurate calculation, we usually use components. In the next video, we will learn the component method, which is the main calculation tool for two-dimensional kinematics.